Another important skill to have in calculus is the ability to distribute. And this is something that you've probably seen before where you'd have like a term in front of a parentheses and then you have some sort of quantity in there. So maybe 4 times the quantity x minus 4. Well, if this is your original function that you're given and you're supposed to find the derivative of that, it's easier to differentiate if you wrote it in the form 4x minus 24 coming from multiplying 4 by the x and 4 by the negative 6. Now, when we have more complex examples, you'll see that this process is very important before we calculate the derivative. If g of x is equal to 3x times 4 minus x squared, you might just think, oh, okay, I can distribute or I can differentiate this part and I can differentiate this part separately and then they just get multiplied together later. But for a couple reasons that doesn't work out. So what we're going to do is actually just distribute here. I'm going to take my 3x times the 4, giving me a 12x. And then I'm going to take the 3x times my negative x squared. Very important to remember the negative sign. This gives me negative 3x cubed. So my g of x function could also be written this way. And then it's easy to find the derivative just using the power rule. Derivative of 12x is just 12. 3 times negative 3 gives me negative 9x to the 3 minus 1, or the second power. So it makes it a lot easier to differentiate, and indeed, had we done it at the very beginning, we would have gotten an answer that doesn't even work out. Let's look at two more complex examples. The next example is a common mistake for many students. So if I consider the function h of x equals x plus 2 quantity squared, once again, we don't have a rule. We only have a rule when it's the variable being raised to a power, but when we have a couple things in there, we don't have that rule. So rather than learn a new rule, what we can do is just rewrite this into a form that we know how to handle. So h of x is going to be equal to x plus 2 times x plus 2, and you might know this by several different forms, kind of depends where you're from. Some people call it double distribution, and then it really just shows what you're doing. You're distributing the x to both, and you're distributing the 2 to both values. Other terms you might have heard are foiling, and double distributing, I think, makes it really clear what's going on. You're distributing twice. This is going to give me my 2x, gives me my 4, and at the end of it, you get an expression, x squared plus 4x plus 4, which is still equal to h of x. But now we can see quite easily that this is a parabola, and we can really easily differentiate it. So if I wanted to take the derivative, h prime of x is equal to 2x plus 4, and it was a lot easier than trying to do it here. Students in standard level or higher level will do expressions like this. The expressions that we see, we'll always be able to rewrite them into a form where we can just use the power rule. One more example, combining both of the rules together. If I consider k of x to be equal to x cubed times x minus 4 quantity squared, I'm just going to a simple rewrite once again. X cubed times x minus 4 times x minus 4. And I'm just going to ignore that x cubed for the time being, and I'm going to do my double distribution. So first I'm going to have x cubed, and then this is still times because x cubed is being multiplied by this whole expression here. This gives me x squared minus 4x, and then using the second number, the second part of my double distribution, minus 4x plus 16. And if I were to simplify what's inside the parentheses here, it's going to make my life easier before I distribute that x cubed. So this will give me x squared minus 8x plus 16, or x to the 5th minus 8x to the 4th plus 16x cubed after I do the distribution here with x cubed. Now that I have that, if I want to take the derivative, k prime of x is equal to 5x to the 4th minus 32x cubed plus 48x squared, and there's my derivative.